Hello, I am Channa Bankapur. I'm going to discuss my solution to the LeetCode problem unique Morse code words. It's today's daily challenge in LeetCode. The problem definition involves Morse codes. Morse code is a way of encoding some text which has English letters and something more than that. But here we're only discussing about English letters. So that way, every letter in English has a code, and the code has only two kinds of symbols like binary. Here there are dots and dashes, right? So every letter of English has a unique code, and a word in English, which is basically a string of letters, can be a concatenation of these codes, right? And such a thing is called transformation of a word, right? So word is English, and transformation of that is in Morse code, right? So we have a few examples of that kind. Say, for example, it's already given here in in this example. GIN. So the Morse code for G is say dash dash dot, and Morse code for I is dot dot, and Morse code for N is dash dot. So that's why this concatenation of this one is there are two dashes followed by three dots and then dash dot. That's going to be a transformation for the word GIN. All right. So what we need to find here is we have an issue in this kind of coding. So there is already a table of all the codes are given here. This is a standard, and uh, not all of these codes are prefix free in the sense that some codes are prefix of another code. Say, for example, for Z, which is Z, dash dash dot dot is the code, right? And look at this G, which is dash dash dot, is a prefix of Z here, which is dash dash dot dot, right? And this is going to create issues. Say, for example, if I have a word which says Z or ZEN, and the code for E is only a single dot, and N is obviously, we already know it is dash and dot. So if you see there, if you have a string which is not even GAN, just GI and ZE, both of them has the same kind of transformation, which is dash dash dot dot dot, right? So that's going to create a problem when we want to decode it, right? When we have a transformation, if you want to decode it back to words, we have an issue, and that issue is basically the problem defined here. If they have given a bunch of words here in English, and if you get the transformations of each of them, some transformations are going to be identical, right? So we need to return the unique number of transformations we're going to have, right? So for example, GIN and ZEN, both of them has the same transformation, so it's going to count as one, right? Because we don't have two different ones. There are other two in this example, GIG and MSG. They are also very similar. Actually, if you look at here, MS, which is another just two-letter word, also has kind of an overlapping or the similar transformation as GI, right? So if you look at M, the transformation for M would be, let's see, it's actually just dash dash, right? Two dashes, and S is going to be three dots. And if you see again, whether it is MS or GI or ZE, all of them has the same transformation. It is dash dash followed by three dots, right? So yeah, because we have GIG and then MSG, both of them are going to be same in the both of them are going to have the same transformation, right? So for this problem, we are going to have only two different or two distinct transformations, and that's why we need to output two here, right? So the approach is, I'm going to use the simplest possible approach. For they have in the input they have given an array of words, and we need to find the transformations of each of them and then find the number of distinct transformations we have. So what I'm going to do is I'm going to use a map in C++, unordered map, or actually not a map, actually just a set is good enough. I'm going to use unordered set in C++, because that is going to be helpful just to keep track of the keys, unique keys. So every transformation, I'm going to treat it as a key and then going to insert into this one, right? So every transformation here. So that way, The unordered set is going to keep track of only the unique transformations, and the number of transformations in unordered set is going to be my answer, right? So that is going to be that simple, and they already have a table here, so I'm going to use that. All right. So let me show you my code, and then that should be clear. So I have this table of Morse codes here already. So this one, then I have this unordered set, which has a string as a key, and that is going to be a transformation. So we are keeping track of unique transformations here. So this is the Morse code table, and this is going to be the set we are keeping track of for unique transformations. Now I'm just going through every word here, and for every word I'm going to get the transformation. So this is the transformation of the word. See, I'm just appending the Morse code of every letter of that word, so that way I'm going to get a transformation. Transformation is essentially a string. I'm going to insert that into the set of unique words, or sorry, unique transformations. If it is already there, it's not going to do anything else. It's just a no op. So that's why this we don't have to worry about, right? If you use some other data structure, you may have to check whether it is present or not. If it is not present, then only insert it. But it's an unordered set. In set, actually, the thing it's not going to insert if it is already there. So that way, when I come out of this one, the size of this unique transformations is going to be the answer, because anything which is repeating is not going to be added there. So even though you call this insert for n number of times, then the number of distinct transformations are going to be what we need. All right. So that's why this works. You know, just with this. Let me run with this the test case they have, and then submit. Right. So it accepted. Right. So this is the quick solution I got. If there are any other ways of doing it, maybe more in a more efficient way, let me know in the comments below. All right. Otherwise, like the video and subscribe to the channel, and thanks for watching.